traffic systems come in all shapes and sizes. Some are very advanced, some are very simple, some go somewhere in between, and no single traffic system fits absolutely everyone. I'll be showing you guys how to set up a traffic system that works with splines, and we'll have an intersection setup where you have green and red lights. You can have cars stop and go, and then carry on and pick a random direction and things of that nature. And not only that, you can see this one looks like it's going low frame rate. In fact, none of these are running on tick. Even though they're following a spline, none of them are on tick. Instead, you actually get to control the update frame rate effectively of these vehicles. So if it's something in the distance, we'll be able to have it far lowered frame rate, maybe go at like 10 frames a second in the distance. We can have it go very high frame rate in the foreground. We'll be able to control that. Now, in this first tutorial, I'm not going to be able to show you how to set up this intersection as well. We're going to first get started with setting up these cars and making them go from one lane to another. So we can have the cars already going from one spline to the next, even when they're not connected. Let's get the traffic system going. To get started, we're going to need a couple of things. First of all, we're going to need the spline for the road. So I'm going to right click, go to blueprint class, grab ourselves an actor. This is going to be our BP underscore road spline, and then go ahead and open the blueprint. All we need here is a spline. So we'll get ourselves our spline component. And to make sure that it's very visible which ones these are, with the spline component selected, in the detail panel, just scroll down here in the editor, unselected color. I'm going to change it from white to maybe a green. That way it's going to be very easy to tell which splines are which, even at a distance, in case we have other splines in the world for other reasons. I'll also go ahead and extend this out just so we have a bigger starting spot. With that, we can go ahead and just drag it out into the world. You can see there's our spline, nice and visible. We can go ahead and select it, hold Alt and make new points. And let's do something like this. And then for testing, I'll drag another one out, maybe over here somewhere, then do something like this. The one thing I'm going to try to make sure is for connection purposes, I'm going to try to keep these kind of straight. So that way the spline from this is either close by or just if it was to continue on, would continue in a straight path. So for example, this one sees an angle like this. So what I can do is just move the tangent so it's just a little bit better. And now it's more straight towards this next point. Now it's very hard to see this on the checkerboard. So I'm going to just change the floor here to default M floor 01. And now we have kind of a track here. Okay, now that we have a basic track, let's go ahead and set up the car. And right click, grab ourselves a blueprint class, type actor, and it's going to be a BP car underscore base. The reason I'm calling it underscore base is so we can create one car kind of template, and then you can create child blueprints of it for all your variations of different cars if you want to swap out the body and things of that nature. Open up the car base, and we're going to need to put in the car in here. In my case, I'm using the default Unreal Sports car. So I'm going to take the two static meshes, and I'll just drag them into the blueprint here. So there's our nice body and our wheel. Now our wheel is not in the right location, so let's go ahead and position it. At the current moment, we're not going to have it spin or anything. We'll take care of that in a future part. For now, I'm just going to duplicate it around to make sure that we have wheels on every side. Now, one thing to note is this body is actually pretty much on the ground, but we want the wheels to be, of course, the ones lower down. So what you can do is go ahead and add a plane to your setup. Now make sure the plane is under default scene root. If it isn't, just drag it on top of it and just say attach. And when you do, go ahead and scale the plane to be bigger. You'll immediately see that, hey, the wheels are actually inside of the ground. We want everything, of course, above. So what we can do is just select everything else and then move the car up. So now it looks more like the car is actually on the ground. So that's good. We no longer need the plane, so I'll go ahead and get rid of it. And because we'll need it down the line, I'll go ahead and rename these wheels. And I just renamed them to BL, BR, FL, FR for back left, back right, front left, front right. It's not necessary, but it will help us down the line. So we might as well just do it now while we're setting it all up. So already we can just take this car and bring it out here. And there we go. There's our car. Okay. And now nothing's going to happen, of course. So we're going to need a few things. We need this car to detect the spline. Now, splines by default don't have collisions. So we need to give a collision box to the spline. So that way we can at the very least maybe line trace to it and get the information of it. But I don't want to use the default object collision channels for this road spline. I want to have its own system, so that way I can make sure I'm only checking for them and ignore it for everything else in the world, so it doesn't affect anything else. If you have a bunch of stuff doing traces for dynamic objects or whatever else, it shouldn't interfere then. To get ourselves a new custom collision channel, we need to go to under Edit, Project Settings, then down below under Engine Collision here, we need a new object channel. When you hit New, you'll get this new channel pop up. I'll give it a name like Traffic Road. And the default response I want is Ignore. I want everything to ignore it by default, and then I will specify when we don't want it to be ignored. Okay, with that, go ahead and hit Accept, and you'll see there's our Traffic Road set to ignore default response with a new custom object channel. We can close out of here at this point. So now let's go ahead and add the actual collision to our road spline. If you have it closed and you select the spline, you can press Control E, and that will automatically open the blueprint no matter where it is in the content browser. So all we're going to do is add a new component here. This is going to be our box collision for it. And if we go to the viewport, you can see there's our box collision. I'll go ahead and just make the extent a little bit bigger. Let's say 150 vertically, so that way we have a nice big one. We can make it wider as well, but for us, it's fine. The main thing is down below, if I scroll down, right here under collision, we want to open up the collision presets. And instead of overlap all dynamic, we want to set it to custom. Now, query only is good. We don't want to have any physics on this, but we don't want the object type to be world dynamic. Instead, we want it to be the traffic road we set up. So with it being a traffic road, I can set ignore everything, but I want to overlap vehicles and I want to overlap other traffic roads. So if I do a trace from either one of those things, it will return like it hit it, which is good. And this also means this will not have any effect on all your custom collisions you might have already set up for your game or project. So if we look back here, we can see, well, we have our car looking backwards because of the way we drew out our splines. So let's go ahead and just rotate the car 180 degrees. So that way it faces this one. We can do something like this. So we'll start going this way and in a counterclockwise direction continue on. At the current moment, we're having to place the car before all of the splines and it gets on it. But later on, we will have an automatic system to spawn the cars. This is just because traffic system's kind of complicated and there's a lot to it. So we're taking one thing at a time. But now let's go ahead and bring our attention to the car. It's a great car, but it doesn't do anything yet. So let's go to the event graph. We're not going to need event tick or actor begin overlap. We'll go ahead and get rid of those. All we're going to need to do is on begin play, I want it to drive, but we don't have a drive function. So I'm going to right click and create a custom event that's just called drive. And by the way, if you're wondering why I don't just use the car preset that comes with Unreal, it has a bunch of physics stuff. It requires skeletal meshes for the car, so it has to have a full rig and everything. And for my setup, I don't think I need all those things. I'm not trying to create a system where I have a bunch of collisions and cars exploding and physics and everything. I just want the city to feel alive and moving. It's possible that we will get very far into it, and at that point decide, you know what, maybe we do want to have physics, and we can add those back in. For the time being, I think this is fine. So now we have a custom event drive. I can say on begin play, drive. Go ahead and just do this event. So what is drive going to do? Well, we need to move the car forward, but I don't want to move it on tick. So we're doing it on begin play, which means I need a timer. And we're going to use a set timer by function name. So we can create a function here. I'll call this drive forward, and I'll go ahead and copy this name and then click to add a new function here and paste that name so it's exactly the same, and then go back to the event graph. Now, I definitely want it to loop, but the time here is basically how much do we want it to update every frame. So what is the frame rate of the car that we want? Let's go ahead and add a new variable. I'll name it something like update frame rate. I will change it to be a float. I'll go ahead and expose it. Then I'll go ahead and compile and select update frame rate, and I'll make the default here 60. By default, 60 frames a second. That's all we need. So now we can go ahead and grab our update frame rate, hold control to get a get node automatically, and then we just need to use a divide. Because if we go ahead and divide 1 by the update frame rate, that will automatically get us the time we need to loop. So that is our frame rate. So now it will cycle 60 times a second. So fantastic. We're going to need a reference to this timer. So I'll right click on this return value and promote to a variable. I'll call it drive forward timer. This way, at any time we can go ahead and stop this timer if, for example, we need to stop. So awesome, we have this. So now let's go to drive forward. Now, we want to drive forward. If we're on a spline, we want to follow that spline. But if we don't have a spline, then we just want to drive forward. Drive forward until we get to a spline and then follow that spline. So first we need a spline component reference that we can check and set to handle all of our, well, directionality in a sense. So I'll go ahead and add a new variable here. I'll call it current follow spline. For its variable type, it is going to be a spline component type. Spline component object reference. When we do that, it will go under the components here, which is completely fine because it is now a component variable. And now we go ahead and drag this out, right click on it, and convert to validated get. So now on drive forward, if it is valid, it'll go here. And if we don't have it set, it will go here. So we're not currently setting the spline. So let's do the is not valid first. We want to move the car forward based on whatever speed we set. So we're going to need a new variable. I'll go ahead and call this speed, and it is just going to be of a type float. I'll go ahead and also expose this and hit compile. And then I will set the default speed to be 1000. To keep things organized, I'll put this update frame rate into a new category. I'll call this controls, and I'll put the speed in there as well. So now when we're driving forward, if it is not valid, I want to set the actor location. I don't need to set rotation, just the location when going forward, because we're not rotating. We're just going straight until we hit a spline. And where are we going? Well, we're going based off the current location. So get actor location plus, because we now need to know how far are we moving. And to know how far we're moving forward, we need to first get the actor forward vector, which is the direction it is facing as a vector. And then we go ahead and multiply it by two things. So I'll go ahead and add another pin. So it's going to be multiplied by the speed. So we'll grab speed and plug that in. We also want to do it based on the frame rate. So we'll also take the update frame rate, drag it out, and we'll need a divide again. So we'll grab this. Now, as you can see, we're starting to use this quite a bit. We're already using one divide by the update frame rate here, and we're using it here. So we're going to be using this quite a bit in other places. So to make our life easier, we can just make a function out of it. So we can just reuse it everywhere. So I'm going to right click on it, collapse to function. It can be done either one of these. I'll name it something like get frame rate. And with it selected, I'll just hit pure here in the top right. It is not doing any calculations in here. If we double click and open it, it is just returning some math. We're not setting variables, so we're good. We can keep this pure, which means it doesn't have an execution pin. And that also means that in here, instead of this update frame rate and the one divided by it, we can just get the frame rate here and plug that in. And now we can grab this and plug that into the addition, and that is going to be our new location. So already we should have the car moving. If we go here and then press Alt S or hit the simulate button up here up top, you'll see there's our car moving forward. And we can have the car selected and then change the update frame rate to something like 5. So we'll update 5 times a second. And now when we simulate, you can see it is updating only 5 times a second. But it is still moving the same distance as it would have if it was just a lot higher update. I can set the update frame rate to 500 and it'll just be very smooth, but it will not go any faster because we're automatically scaling the speed by the update time. So awesome, we already have the car moving forward. Now we need to have the car move forward and detect a spline. So what I'm going to do is just do a sphere trace in front of the car whenever we're moving forward so we can see if there's a new spline kind of down the line. So for that, we'll need a new function. I'll call it trace for new path. And after this set actor location, we want to make sure we're tracing for the new path because every time we drive forward, move forward, and we check. Let's go ahead and open it. And now in this trace for new path, I'll be doing a sphere trace for objects. Now the reason we're doing objects is so that we can drag out of object types, search for make array. Instead of world statics, we can say traffic road. And this is why we created that custom collision channel. So now we can do a sphere trace specifically for those road splines. Okay, well, let's say the radius for it will be about 100. I think that is plenty. Now, where are we starting and going to the trace? Well, we want to start from our current location. So right click, get actor location. That is where we're starting. And where are we going? Well, the and location will be in front. So we're going to do an add. And just like before, right click and get actor forward vector. And again, we're going to multiply it just like the other one. But we're multiplying it by something a little bit different here. The first thing we need to scale by is the get frame rate. And make sure you get the get frame rate and not the update frame rate, or it's going to scale by a lot. We don't want that. We want the get frame rate. And the second one is the speed. But I want to not just check just in front. I want to check a little bit further down. And depending on how far ahead we want to check, we just multiply it by that number. For example, if I scale it by 5, we'll check that far ahead, and then we can plug this all the way through into the addition and into the end. And by changing the draw debug type for 1 frame, we can take a look at what this looks like. And we don't really see it. Well, why don't we see it? It's because this is just too low. If we go ahead and set it to 20, there we go. 20 is the distance now we're checking in front. And you can see as it continues, it's checking all the way from where it's overlapping to a little bit in front. And that distance honestly is enough. And you can see there, as it overlaps this, it finds the spline, which is perfect. So now we can go ahead and turn off the debug. We know it's overlapping. We know it's finding the right thing. So now if it finds something, we'll go from the return value here and check as condition here. If it is true, it did hit something, then we'll take the out hit and break it to get all the information about the thing that it hit. And over here, we don't actually need to check that it hit the right thing. It is the only thing it can hit. Nothing else in the world has this collision response. class. So we automatically know that it is a road spline and it probably has the spline component we need. So we just set the current spline component. Now it will involve some timing stuff, so I'll go into the event graph and make a custom event here. Right click, search for custom event. I'll name it to set current spline component. And this will need two inputs. The first one is going to be the spline actor, whatever actor it is that we're using. The type here can just be of a simple type actor object reference. I don't need it to be anything more advanced because we'll be able to get the spline regardless. And there's no reason to make a hard reference here. The next thing is going to be the hit component that it actually hit. So we'll call it hit component. And this is really the box that it hit, that box collision. Now the box collision is not an actor. It is actually a scene component object reference. So we'll call it hit component, and it is of a type scene component object reference. And if we go back to our trace for new path, we can drag out of true and search for set current spline component and call that function. And now we can take this hit actor, plug that into the spline actor, and the hit component into the hit component, and close this up. So assuming it overlaps something, go ahead and trigger this. Now you might be wondering, why don't I just immediately set the spline? We're setting the position based off of the actual just moving forward timer, or we're going to be doing it based off of the position of the spline. If we now all of a sudden are, let's say, 1,000 units away from the spline and the spline is valid, that means our car would teleport 1,000 units to that spline no matter what, because that's now going to be tracking the spline. So what we need to do is say, hey, you got the spline, fantastic. Now just wait for us to get close enough, at which point go ahead and activate it. And then we will follow the spline. And because of this little extra wait, that's why we're also doing it on the event graph. Let's go ahead and set that up. So some simple stuff. Well, the spline actor, we need to get the spline component. So we can drag out and search for get components by class. Now this is components, plural, by class. The reason I'm doing plural here is so down the line when we do the intersections and there's potentially multiple ways to go, it'll be able to pick a random one. So we can go straight, left, right, whatever we decide as possible ways to maneuver. And the component that we want here is, of course, the spline component. So now we have the spline component from the actor, and I just want to grab a random one, random array item. And this random array item is going to be setting our current follow spline. But again, we don't want to do that immediately, because watch what happens if we do this immediately. I'll compile this and then simulate. As it's moving forward, it will immediately stop because it reaches it. But you can see here, it was moving very slowly, and you see the distance between here and here. It would teleport at this point, and we don't want it to teleport. That looks bad. So let's make sure we can get closer first and then assign it. So we have the hit component. We know where the start of it is. So I can drag out here and search for get world location, and we can compare it to our current location, get actor location. And as long as the distance vector between these is within a certain distance, we're okay. So as long as this distance is less than the speed multiplied by the get frame rate. Basically, as long as the distance there is small enough where it would make sense for us to just start following it without just teleporting kind of and making really bad movements, that's when we do it. So assuming this is true, then go ahead and set the current follow spline. Now what happens if it is not true? If it is not true, well, I want it to wait for a moment. So we'll use a delay, and the delay will be, again, the get frame rate. So it'll wait based off of how fast we want to update and then try again. Because it's always moving forward and it is tracing forward, it will be pretty much close enough for this to be fine. Now, there are a little bit of caveats with this, and it won't matter down the line once everything's set up, but just so you know, this distance assumes that everything lines up. If I have a car following the spline here and it gets to the end and it continues forward, it will continue forward this way. Even if the trace somehow got this spline, let's say it was here, the center of the car would actually be still too far away here to grab it. So all of this has to do with me basically saying you want to make sure that the end of one spline is straight into the next spline. Now, it doesn't matter if the rest of it is the way it is. We could very well just have a very slight section here that is straight and then it just goes like this. That doesn't matter as long as that very end piece is straight into the next one. Less important once everything is set up because it will pretty much all line up automatically. But if you're replacing them right now for testing, just know that's a thing. And if you want to increase the distance that it checks, you can go ahead and hit plus here and increase it by whatever you want. Let's say 10 times bigger. So if you're a little bit too far on the sides, it will snap. You will visually see that snap though. So keep that in mind, which is why I'm not doing it for mine. I'll just make sure that it's all lined up. So this is all we need for the setting of the spline. And now if I go ahead and simulate again, you'll see it now went all the way until the middle of the car touched the start of it. Perfect. So at that point, it said, yes, I have a spline and I have assigned it. And the reason, of course, it stops is because is valid here doesn't do anything. So now we need to say, hey, we have a current follow spline. We now want to follow that current follow spline. So not only do we want to move forward, we also want to rotate based on that spline. The beauty also of using splines like this is that if you have different hills and want to go up, down, or curve it, or whatever you'd like. For example, you want to have a freeway that kind of tilts as it goes. The cars will just automatically do that because it will just follow the curvature of the spline. So from the is valid, we want to right click and do set actor location and rotation. Is valid, set actor location and rotation. And now how do we know where to go? Well, go a little bit to the left here and we want to grab the current follow spline and then we can find out where we are relative to it. So from the current follow spline, drag out and search for get distance along spline at location. So get distance along the spline at closest point of the provided input location, and the input location is ourselves. So get actor location. From our location, what is the closest position on the spline? Now we want to make sure that this position is world location. All of these need to be world. Nothing here is relative. So be very careful not to leave any of these as a relative. So we know the distance along the spline we are. So now we need to know how much we want to move forward along that spline. So we'll use an add. And just like before, we just need to multiply the speed by the get frame rate. So let's copy it and paste it here. And I'll add that forward. That is our speed effectively. So, okay, that's how much we're moving forward. So now we need to find out, hey, where along the spline would we be if we continue this distance along the spline? So from the current follow spline, I'll drag out and I'm going to search for get location at distance. So we can grab the get location at distance along the spline. Again, make sure to set to world. And the distance is now this new location. So we first found the closest point on the spline. And then we said, hey, a little bit further down, what location is that? And now that is our location. So we can go ahead and take this location and plug that into our new location here. Now, just like there is a get location at distance along spline, there is also a get rotation at distance along spline. So we can use this as well. Again, world rotation, same input for the distance, and this becomes the new rotation. So we're going to go ahead and compile this. Let's see what happens when we go ahead and simulate. There it goes, and now it's following the spline. Look at that. And when it gets to the end, it will stop. The reason it stops is because it is still having a valid spline and it's reached the end. There's no point afterwards where it can go. We have not told it to stop tracking the spline. So we do that. The way we can do that is by checking what is the final location on this spline. So if we know the final location, we can say, hey, is our car within a certain radius of this location? If it is, let's just assume that we've reached the end. If we reach the end, clear the spline. We no longer need to track it. Now we want to do this after this actor location and rotation. So we know where the car is. It was just set. So we're going to right click and do get actor location. And I want to see if it is equal to the last point of the spline. So we're going to take the current follow spline and then drag out and search for get location at spline point this time. So whatever the location at a certain point is the one we want. Now we don't know how many points there are, but thankfully we can just drag out, search for number, and there's the get number of spline points. So now we know how many spline points there are, but keep in mind, the number of spline points is not the index. The index is always the number of points minus 1. Because you start counting at 1, 2, 3, 4, but the index starts at 0, 1, 2, 3, 4. So number of spline points, subtract 1 will get us the last index, and that can go into point index. Again, make sure it's set to world, and then go ahead and compare these two. And this number down below is basically approximately how close do you want these numbers. So if they're within 25 units, I think we're fine. You can absolutely also do the other way around, which is just using a distance vector and then just saying, hey, is the distance here less or equal to 25? I'm just showing you another way of comparing these two vector locations. In fact, let's go ahead and just say it's 75 because 25 honestly is way too small. So if this is true, if it is within that distance, we'll go ahead and add a branch and go ahead and plug it all the way through and say, hey, this is true. It is at the end. So now we can go ahead and set the current follow spline to be nothing. With nothing plugged in, it clears it, which means that it will no longer be valid here and it will continue down this path again the next time around. So now if we take a look, if you simulate, it goes ahead and starts following the spline, following the spline, following the spline, and then gets to the end. And then there it is, following the next spline. As you can see, automatically continuing along, and then it's going to run out of this spline, continue forward, and then there we go. That's what happens right there when they don't quite line up because the distance there is just a little bit too much. So we go ahead and come here to fix it. I'll go ahead and select this, and I'll honestly, just to make my life easier, I'll just line it up a little bit closer here for this demonstration. Something like this. And now if I go ahead and play, you can see it is now following the spline here, and it'll stop at one without taking a beat and go on to the next one. Continue, 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 all the way around. And now it'll go back to this one. And just like that, we have the car continuously going from one to the other. And we can go ahead and select the car and change the update frame rate to, let's say, 5, and then hit play. And even then you could see, hey, the car is still moving along and is still moving along the spline at 5 frames a second, just like it did before. No matter what, it is still continuing now at 5 frames a second. Obviously, you're not going to want to update it actually at 5 frames a second, but maybe down in the distance, at a certain distance away, you just want to know where the location of the cars are. You don't really care to see them. Maybe that's all you want. The point is, if you want, you can have them be super smooth or a little bit more performant by having it update less often. Now, there's still a lot to do, and I would love to show you guys how to have them speed up, slow down, and do intersections already, but this video would be extremely long then, and I wanted to get you guys started without overwhelming you with thousands of things right away. But up next, we will be visiting intersections already. So that way we can have things going from one spline, stop at an intersection, and then continue going when it needs to. That'll be the next video, which is what you saw at the beginning when I was showing off where I was in my little demo. In the meantime, though, the project for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to that and everything else will be in the description down below, as always. If you want to see where we're going to be using this traffic system and get yourself set up to use it, check out my CityGen series, starting with generating the streets themselves.